Good morning, everybody. My name is Collins Emmanuel Oje. I'm a member of Python Data Science team. I will be your presenter for today. Today's presentation is titled Encryption and Decryption with Python. When we talk about encryption or decryption, what we're actually talking about is to encode and decode data or useful information, as the case may be. It's just the process of encoding a message, hiding vital information from unauthorized access. So encryption, just like I said earlier, is a process of encrypting a message using an encryption key or algorithm, and then it generates a ciphertext. The ciphertext is what you pass on to the person on the other end who is to decrypt it and then get back the readable information, as the case may be. So encryption is the process of converting information or data into a secret code or cipher to protect it from unauthorized access. It involves using an algorithm or mathematical formula to scramble the original data, making it unreadable and meaningless without the correct key or password. Encryption helps to ensure that only authorized individuals can understand and access the protected information. And then what is decryption? Decryption is just the opposite of encryption. It's the reverse of encryption. Whatever you encrypted has to be decrypted for you to get back the original message. And the same procedure, just that you twist it around. So it's a method of converting the encrypted or coded data back into its original readable form. And decryption requires the correct key or password to reverse the encryption process and restore the information to its original state. It allows authorized individuals to access and understand the protected data that was previously encrypted. Why do we use encryption and decryption? Number one is for security. Common reason for secure information, so that unauthorized individuals or entities do not gain access to such data/information. Encryption and decryption, they are fundamental techniques used in information security to protect sensitive data from unauthorized individual or access and ensure its confidentiality, integrity, and authenticity. Encryption involves converting plain text into ciphertext using an encryption algorithm and a cryptographic key. While decryption, on the other hand, is the reverse process of encryption. It involves converting the same ciphertext back into plain text using the decryption algorithm and the correct key. And by employing decryption, authorized individuals or entities can regain access to original data and read its contents. How can Python help us with encryption and decryption? Python can help with encryption and decryption through its extensive cryptographic libraries and built-in modules. By utilizing libraries like cryptography or PyCrypto, Python enables us to implement various encryption algorithms such as AES, RSA, or DES, and perform encryption operations on data such as encrypting messages, files, text, PDF, documents, or whatever. While conversely, Python also allows us to decrypt this same encrypted data by providing the necessary key and algorithms, enabling secure transmission and storage of sensitive information, and as well as facilitating the creation of secure communication channels and the protection of confidential data. Encryption basis. There are basics to encryption. Every time you choose to encrypt a particular information or data, you convert that. If it's, let's say it's plain text, it's text messages, you have to convert it into ciphertext. And then ciphertext is just a bunch of characters, meaningless characters. I tag them meaningless because when you see a ciphertext, as you will see later on in the presentation, it's meaningless. You can't read it. It's just there. You're just seeing a bunch of alphabets that have zero meaning. And anyone who is not skilled in cryptography will just look at them and overlook them. But an average cryptographer can easily decode that this must be an encrypted message, and applying some using using Python's cryptographic libraries, they can decode the encoded ciphertext. So, and then encryption also ensures that only authorized individuals can access the information. So types of encryption algorithm, we have two types of encryption algorithm. The one that uses the same key for encryption and decryption, and the one that uses a different key for encryption and decryption. The symmetric key uses the same key for encryption and decryption, while the asymmetric key encryption uses different key for encryption and decryption. So example, encryption with Python. Some of the Python libraries used for encryption and decryption are cryptography, PyCryptodome, and we have others, but cryptography and PyCryptodome, they seems to be one of the most popular in Python for encryption and decryption. So, and then these libraries, they offer the various encryption algorithms like AES, ROSA, and several others. So without wasting time, this is a short Python script for encryption and decryption. Although it's just for educational purposes, this is not how it's actually done in a real life scenario, like when you're building an app or trying to send an encrypted message to an organization or entity. There are way more secure means that the encryption process is done, and then on the receiving end, the decryption process, which is the reverse case, is also being done. But for the purpose of this presentation, I haven't used any specific encryption library. This is just basics for all of us to have an understanding of what happens whenever we are dealing with some web applications or utilizing bank applications, and then you're asked to put in your password, verify password, confirm password. It's just, this is just the process. So let me take us to this code that you're seeing. This function talks about the function, the definition, the encrypt function deals with the encryption process, and then I have the decrypt function, which also defines the decryption process. So let me show us this code and explain it better. So how this is done, from line 1, I imported random and time. Random is just to generate random characters from alphabet, and time is just to slow down the encryption and decryption process. So this function definition define for encrypt plaintext key. The encrypt takes two parameters: plaintext, which is the text that we are trying to encrypt, and then key, which we are using as the encryption key. Then ciphertext, which is the ciphertext that we're generating after we've encrypted our plaintext. Here it's set to empty string because we have not generated it yet. And then there's a for loop on line 6 that goes through our plaintext from 0 through the length of the plaintext, and then it appends each specific character from the range. It appends it to a variable named character, and then ciphertext adds this character to ciphertext. So the empty string plus this character, it begins to append them into ciphertext. And then the next loop for J in range 0 key, it goes through a range of 0 and the key, the number that we have used as our encryption key. It goes through the range and then picks a random number. From random.choice, picks any random of its choice from this alphabet. And then at the end, it returns when it has gone through the loop thoroughly, according to the characters of the encryption key and the plaintext. It returns our ciphertext, which is now the encoded message. So down here, what this is just doing is we input the message that we want to encrypt, which is the plaintext, and the number between 1 and 10, which we are using as the encryption key. So then this while loop here is just to tell us that the encryption key that we are using should be between 1 and 10. Anything below 1 or above 10, it throws an error that it's an invalid key. We try again. So when you put in a key between 1 and 10, our plaintext gets encrypted. This prints and then time.sleep. This is just to delay the simulation. So while at it, it prints out our ciphertext. So let me run this program so that we can actually see how the process is being encrypted and also how it gets decrypted as well. So just a minute. Yeah. All right. Yeah, from here, I'll run this Python script just for the first part, which is the encryption. It says enter the message to encrypt. I could put in any message at all, any message. I could go with today is Tuesday. Yay. Then I have to put a key, which is the encryption key. Between 1 and 10, anything above or below will blow up. So let me go with number 8 as our encryption key. So then this process that is just happening is this print statement, this print time.sleep. It's just to delay the simulation. So now this is our ciphertext. This whole bunch of meaningless characters, like I said earlier in the definition of ciphertext, it's just a bunch of meaningless character that to the eyes you will not be able to make sense of what you're seeing. So now this message today is Tuesday, yay, has been encrypted, and then it returns the ciphertext, which is this message. So in order for us to decrypt this message, we will need the ciphertext and the key used for encryption. Anything that does not tally between the ciphertext and the key used for encryption, our code will blow up and it will throw up a bunch of other meaningless characters that we may not be able to make sense of it. So then for the decryption process from line 38, it asks for the ciphertext, which is the ciphertext that we had, the ciphertext that was returned after we encoded the plain text. So then it requests for a key. Of course, the key that was used for encryption, which was number 8. And if you use a different key entirely, you get something else. You never get the plain text. All you just get will be a bunch of errors upon errors. So then this function definition, this is the decrypt function, where it takes in 2 parameters, the ciphertext. Remember, the encrypt function took 2 parameters, the plain text that was encrypted and the key. While for the decrypt function, it's taking the ciphertext, like from when we defined encryption and decryption. Decryption is the reverse case of encryption. So instead of taking plain text, it's taking the ciphertext now plus the key. And then plain text becomes empty string. So it goes through the range 0 and the total length of the ciphertext. If any character from this ciphertext is divisible when you add the key that was used for encryption by 1, if you divide them and it gives you 0, it appends it to plain text instantly. It appends that character to plain text. And then when it has gone through the total length of the ciphertext, it returns plain text. And then for this logic here, this is the same thing we did here. It checks to make sure that the key is not less than 1 and the key is not greater than 10. So anything up below 1 or above 10, it tells you to enter a key, which means the key that you have entered is incorrect. Enter a key. So this logic is just to make sure that whatever key that we are putting has to be between 1 and 10 for decryption. Then here we call the function, which is the decryption function here. We call it places in, adds it to a variable plain text, and then this line 56 to 60 is just to delay the decryption simulation. It prints empty line and then it sleeps to allow the decryption process to continue its simulation. After which it prints our decrypted text. You'll get it as plain text, which is this plain text here. So please enter, running the program from below. It's asking, please enter a text to decrypt. This ciphertext, I'll place it here as the text which we want to decrypt. I'll press enter, then it will request for a key, and the key that was used for encryption, I have to also key it in for decryption. Anything less than the exact key, I'll get an error. So I'll make sure I'm using number 8. So we get our encrypted message, the message that we had encrypted, which was the plain text. Today is Tuesday, yay. Now we have decrypted it, and this is what we are getting. So this is just the basics of what happens in the background every time you hear encryption and decryption. It's just to hide confidential message from unauthorized individuals such that they don't get access to your information or data. Only authorized people can access it. So moving on, some of the real-life applications of encryption: secure communication, emails, messaging apps, and several others. Every time you log into an email, you put in your password. It is not the password that is actually being stored in the database. Rather, that password that you're filling gets encrypted, and it is the encrypted message, which is like the ciphertext, that gets stored in the database. And then when you try to log in again, you put in your password. The process that was used to encrypt your password that was stored in the database, the same reverse process takes place. It checks to see if the decryption process and the plain text that you're filling in tallies. If yes, it returns a secure login, and if no, you'll get an error that password is wrong. So the same thing with banking and transaction. If you're using your online banking application, if you put in your password, it is the encrypted message that it is the encrypted password that gets stored, which is the securely encrypted password that gets stored on the database. So it is for security. The essence of it is to keep your data secured from unauthorized access. So even if the platform gets hacked, nobody gets to see your real password that you have stored on that platform. Rather, they get to see maybe the encrypted data. So when you try to log in again, the same process happens. It retrieves the ciphertext that was stored and then checks to see if everything corresponds accordingly. If yes, you are allowed access. So another reason for applications, real-life applications of encryption, is for data protection, data privacy, and security, just like I said earlier, to keep your privacy and security safe from unauthorized individuals or access. So in conclusion, encryption and decryption are essential for secure communication and data protection. And Python provides powerful libraries for implementing encryption and decryption algorithms. Understanding encryption helps us protect our personal information and maintain privacy. Thank you.